How do the discharge curves obtained from constant current tests complement the findings from CV, and why is it necessary to analyze both in order to gain a full understanding of a material's energy storage potential? In what ways can a schematic diagram of the constant current discharge curves highlight differences in discharge times, voltage stability, and efficiency among various energy storage materials? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the shape and behavior of the discharge curve correlate with the electrochemical properties revealed in the CV tests, and why is this important for evaluating the practicality of these materials in real-world applications? What can be learned from examining both the CV and discharge curves together, and how does this combined analysis inform the optimization of energy storage materials for higher performance in devices like batteries or capacitors? How do these two types of tests, cyclic voltammetry and constant current discharge, work in tandem to provide a deeper understanding of a material's suitability for energy storage applications? And how can they guide the development of more efficient materials for future technologies? What does it mean to use different voltage scan rates, nu, in MV_S-1, in electrochemical testing, and how do these scan rates affect the behavior of batteries during charging and discharging? Why is it important to distinguish whether a battery exhibits diffuse or pseudocapacitive behavior, and what are the key characteristics that differentiate these two types of behavior in energy storage systems? How do scan rates play a role in determining whether a battery's behavior is more diffuse or pseudocapacitive, and how can this distinction be made by examining the resulting peak current response? What is the significance of the peak current response in relation to the scan rate, and how does this relationship provide insight into the electrochemical processes occurring during charge and discharge cycles? How does the corresponding scan rate affect the peak current during charging and discharging, and why is it necessary to study this effect to better understand the battery's performance? What role does the equation used in this context play, and how does it help quantify the relationship between scan rate and peak current response? How does the calculation of this equation allow for a clear distinction between diffuse and pseudocapacitive behaviors in batteries, and what are the underlying principles that this equation captures? Why is it important to apply this equation accurately, and what information can be obtained from its result that aids in understanding the kinetic mechanisms governing charge storage in batteries? How does the ability to distinguish between diffuse and pseudocapacitive behavior influence the optimization and selection of materials for energy storage?